In this lesson, we're going to practice operating with fractions, and that means adding, subtracting, multiplying, and dividing. When we're operating with fractions today, we're going to give our answers in improper fraction form. So we're going to simplify them, but the numerator can be bigger than the denominator. Okay? So first thing we're going to do is add. When you're adding and subtracting fractions, they must have a common denominator. We'll look at the fractions that we're adding, and if they do not have the same denominator, we will multiply one or both of the fractions to create equivalent fractions with common denominators. Okay? And then after that, we'll add or subtract the numerators, and we'll keep that common denominator on the bottom. So after we get a common denominator, that common denominator will carry through to the end of the problem. And then at the very end, we'll simplify if possible. That may get rid of the common denominator, or it may not. But the reason we create that common denominator is we put that on the bottom of the answer. So don't be tempted to add the denominators as well. All right, so let's look at example 1a. We have 1/4 and 3/2. So what we want to do is create an equivalent fraction for this second fraction that has the same denominator as the first. So this has a 4 on the bottom. So in order to get a 4 on the bottom here, we would need to multiply by 2. So I'm going to multiply by 2 on the numerator and denominator. And I'm going to recopy my problem down below. So I have 1/4 plus 3 times 2 is 6. 2 times 2 is 4. So now I have common denominators. So I'm going to add straight across the top. 6 plus 1 is 7. And I'm going to keep that common denominator 4. So this is an improper fraction. There are no common factors shared by the numerator and denominator. I couldn't divide both of these numbers by the same thing, and so this is in simplest form. And that one's done. This next one is a little bit trickier because I can't just multiply 3 times something to get 8. So I'm going to have to find the lowest common multiple of 3 and 8. So I'm going to start with 8, and I'm going to list the multiples. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And I know that 3 doesn't go into 8, and it doesn't go into 16, but 3 can go into 24. So I'm going to use 24 because those two numbers can multiply up or scale up to 24. Okay, so I'm going to multiply the first fraction times 3, because 8 times 3 is 24, and I'm going to do that on both the numerator and the denominator. And then to get 3 to be 24, I need to multiply by 8. So I'm going to multiply this fraction by 8 on the numerator and denominator. So I'm going to recopy my problem down here. 3 times 3 is 9. 3 times 8 is 24, which that was my goal. This is a subtraction problem. 1 times 8 is 8. 3 times 8 is 24. So now I have that common denominator. So my answer here is going to have that same common denominator of 24. And then 9 minus 8 is 1. This is in simplest form, and so this one's done. All right, last one for example 1. We're going to have to do the same thing. I can't multiply 5 to make it equal 6, and I can't multiply 6 times something to make it equal 5, so we're going to find their common multiple. So the multiples of 6, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. So always these two multiplied times each other will give you a common multiple. It won't always be the lowest one. But you can see on these two examples, that was the case. So I know 30 is divisible by 5, 6 is not divisible by 5, or 12, or 18, or 24. So this is the smallest number that I got as a multiple of 6 that is also divisible by 5. So we're going to scale both of these up to create equivalent fractions. So I'm going to multiply by 5 on the first fraction, and 6 on the second to get a denominator of 30. So 5 times 2 is 10, 5 times 6 is 30, 2 times 6 is 12. 5 times 6 is 30. So now we've got our goal of our common denominator here. So that's going to be the denominator on our answer, on our sum. And 10 plus 12 is 22. Now these are both even numbers and they're both divisible by 2. So in order to simplify, I'm going to divide both numerator and denominator by 2. 22 divided by 2 is 11. 30 divided by 2 is 15. So 11/15 is the answer. Now in example 2, we have some mixed numbers. So we're going to convert these mixed numbers to improper fractions before we try to add or subtract them. So in this first one, we have 1 2/5. We're going to multiply the whole times the denominator and add the numerator. So 1 times 5 is 5, plus 2 is 7. So our new numerator is 7, and our denominator is still 5 here. And then 4 times 2 is 8, plus 1 is 9. So we have 9 halves here. Next, we want to find a common multiple of 5 and 2, which is 10. So I'm going to multiply this fraction by 2, numerator and denominator, and I'm going to multiply this one by 5 on the numerator and denominator. So now 2 times 7, it gives me 14/10 for my first fraction. 9 times 5 is 45. So that gives me 45/10, and now I have my common denominator. My answer will have that same common denominator, 10, and I'll have 59/10. 59 over 10 cannot simplify. We can't divide both numerator and denominator by a common factor, and so that one is complete. Next, we'll do the same thing here, but with subtraction. 3 times 8 is 24. 24 plus 5 is 29. So that gives us 29/8. And then here, 1 times 4 is 4, plus 1 is 5. So we've got 5/4. I can multiply 4 times 2 to get 8, so I only have to multiply the second fraction in this problem. So now I've got 29/8 minus 5 times 2 is 10/8. I've got my common denominator of 8. My answer is going to have that same common denominator. And then 29 minus 10 is 19. 19 is prime, so I know I can't divide to simplify these. And so that one's done. All right, last one. 3 times 9 is 27. And then add 4, you get 31/9. 2 times 3 is 6. Add 2, that gives you 8/3. So we've got 31/9, 8/3, and we can multiply this second fraction by 3. So now I've got 31/9 here, and 24. 8 times 3 is 24. 9 here, I've got my common denominator of 9. And 31 plus 24 is 55. And 55 and 9 cannot divide by a common factor, so that one is also complete. Now we're ready to move on to multiplication. All right, when we're multiplying fractions, we will just multiply straight across the numerator and straight across the denominator. And then once we get those two products, we'll simplify if possible. So don't forget to simplify when you're finished. Okay? So example 3a, we'll multiply straight across to get 2 times 5, which is 10 for the numerator, and straight across the bottom 3 times 6, which is 18. Then we could divide by a common factor here. Both of these are divisible by 2. So we'll divide both the numerator and the denominator by 2. 10 divided by 2 is 5, and 18 divided by 2 is 9. Next problem, we'll do the same thing. 1 times 5 is 5, and 10 times 21 is 210. This seems a little scary because that's such a big number, but it's easy to see that they're both divisible by 5 because any number that has a last digit of 0 is divisible by 5. So I'm going to divide numerator and denominator by 5 to simplify. And so 5 divided by 5 is 1, and 210 divided by 5 is 42. On these examples down here, we'll need to convert, especially this one, we'll need to convert these mixed numbers to improper fractions before we can multiply here. So 1 times 2 is 2, plus 1 is 3, so I've got 3 halves here. And then 2 times 4 is 8, plus 3 is 11, so I have 11 fourths here. So now I'm ready to multiply. 3 times 11 is 33, and 2 times 4 is 8. And again, we have an improper fraction, and that's fine. The instructions say write your answer as an improper fraction in simplest form. And then last one, we have a 4 here, and this 4 has an understood denominator of 1. So the 4 is on the top, and the 1 is on the bottom. So we are multiplying 4 over 1 times 1 over 4. 4 times 1 is 4. 1 times 4 is also 4. 4 divided by 4 is 1. And that one's finished. Now we're ready to move on to division. Now, dividing with fractions can be a bit tricky, and you've probably learned some tricks about how to do it. But before we start actually practicing this, I want to talk about what it means. So when I am dividing, if I'm dividing 8 by 2, what does that really mean? 8 divided by 2 means how many groups of 2 are in 8. 12 divided by 4 means how many groups of 4 are in 12. So let's illustrate this and see what we're talking about here. So I'm gonna draw some circles. Oh, some of them are gonna make nice circles and some of them aren't. Okay, so I have 8 items. I'm starting with 8 things, and I'm dividing them into groups of 2. All right, so I have 1, 2, 3, 4 groups of 2. So 8 divided by 2 means how many groups of 2 are in 8, and the answer is 4. Now let's do 12. So now I need 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we started with 12, and we want to know how many groups of 4 are in 12. So we'll try that again. Here's a group of 4. Here's another group of 4. And here's a third. So there are 3 groups of 4 in 12. Now let's talk about what this means with fractions. So 3 divided by 1/2, it means the same thing as it did up here. How many groups of 1/2 are in 3? So I'm going to make 3 circles here. I'm going to make them a little bigger because I've got to divide them in half. Okay, let's pretend that I can draw the circles all the same size. All right, so we're dividing them into groups of 1/2. So I need these circles to have halves. So I've got 3 items, and they've all got halves, and now we're going to determine how many groups of 1/2 are in these 3. So here's a group of 1/2, and here's a group of 1/2. Here's a group of 1/2, and here. And then finally, we've got 2 more here. So there are 1, 2, 3, 4, 5, 6 halves in 3. And it goes a little bit against our instinct because when we think about fractions, we think about numbers becoming less, but the result was actually more because there are more halves in something than there are wholes. If you divide things in half, you could hand that out to a lot more people than if you just gave each person a whole thing, whatever it is. All right, so now let's look at 4 divided by 1/3. Again, we're starting with 4 items, and we want to know how many groups of 1/3 are in those 4 items. So let me move my little floating head out of the way so I can make my 4 items. So 1, 2, 3, and 4. And in this situation, we're looking at 1/3. So I'm going to divide each of my circles into thirds, which is kind of tricky, but it kind of looks like this. So 1, 2, 3 pieces in each circle. Oh, I'm getting worse with each one, but there we go. We've got our thirds. So now we're going to determine how many groups of 1/3 are in these 4 circles. So we've got, maybe I can, it's not going to be a square anymore, so maybe I can highlight them instead. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 thirds in 4 whole items. Last one, we have 3 halves divided by 1/4. This one is a little bit advanced. So we're starting with 3 halves of a thing, okay? So I'm gonna make, basically that's one whole circle that's divided in half, right? So there's 1 2 halves, and then I'm gonna need another half of a circle. Now that's the best I can do, alrighty? So, well, it went away. No, it's trying to auto-create shapes for me. There we go. Okay, so I still don't like that because it doesn't look like an actual half. Let's try one more time. There we go. All right, so we want to know how many fourths are in these 3 halves. So really what we're going to have to do is divide these up additionally. So right now I've got 1/2 and 1/2. To make it fourths, it's going to be cut again. And so we want to know how many groups of 1/4 are in 3 halves. And we've got 1/4, 2/4, 3/4, 4, 5, and 6. So we've got 6 groups of 1/4 within this 3 halves of an item. Interesting, right? So let's take a look and see if we notice some patterns in the problems up above. What do you notice about the results of C and D? We already know how A and B work. Let's look at C and D. You notice that the result was 6, and the 2 numbers that we were working with were 3 and 2. The result over here is 12, and the numbers we were working with are 4 and 3. 4 times 3 is 12, and 3 times 2 is 6. So what really happened here, when we divide by a fraction, the number actually becomes larger because we're multiplying that first starting number by the denominator of the second number, or the fraction, okay? So result of dividing by a fraction is the product the first number and the denominator of the second. So if we took the front number 3 and we multiplied it by 2, we would get 6 in the same manner. Now this takes into account only if the numerator of the fraction is 1. So let's see if we can apply that same pattern to E, where the first number was a fraction. So our first number is 3 halves, and then we're going to multiply by the denominator of the second, which is 4, and that'll be 4 over 1. So 3 times 4 is 12, and 2 times 1 is 2, and 12 divided by 2 is 6. And that is exactly what we got when we illustrated that same scenario. Now again, this is taking into account only if the denominator flips up and the numerator to the bottom is 1. So let's see how we account for that if, when we flip that fraction, there's a new number on the bottom that's not 1 as well. I'm going to apply that pattern that we observed to our dividing by a fraction problems. And when we're dividing by a fraction, we're going to keep the front number just like we did up above, and then we're going to change to multiplication. So we're going to keep our front number the same. So each of these is going to remain the same. We're going to change the division to multiplication. So each of these is going to become a multiplication problem instead, and we are going to use the reciprocal of the fraction we are dividing by. So we're going to flip each of these fractions and write it as its reciprocal. So let's try one. We're going to keep our front fraction the same, and we have to keep the front one. You can't flip the front one and keep the second one. You have to keep the front one the same. So 5, 6, we're going to change this division to multiplication, and then we're going to write the reciprocal of 2/3, which is 3/2. So we've rewritten our problem as 5, 6 times 3/2. Now we can just multiply straight across the top and straight across the bottom. 5 times 3 is 15, and 6 times 2 is 12. And then we can simplify, dividing both the numerator and denominator by 3, which will give us 5/4. And we've written our answer as an improper fraction in simplest form. Next, we're going to keep the 12. We're going to change the multiplication to division, and we're going to write the reciprocal of 2/5, which is 5/2. Now, there's an understood denominator of 1 here, so we're multiplying 12 times 5, which is 60, and 1 times 2, which is 2, and then we can simplify that to 30. For C, 3/8 will stay the same. We'll keep that fraction, change our division to multiplication, and we'll write the reciprocal of 3/4, which is 4/3. 3 times 4 is 12. 8 times 3 is 24. Both of these are divisible by 12, so I'm going to simplify dividing both by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. So we got 1/2. And last one, we're going to convert this to an improper fraction. So 2 times 2 is 4, plus 1 is 5. So our new numerator is 5. Denominator stays as a 2. Change to multiplication. Flip this fraction, so that's going to be 4/3. 5 times 4 is 20, and 2 times 3 is 6. Both this numerator and denominator can divide by 2, so I'm going to divide by 2 to get 10/3. And that's it. We've added, subtracted, multiplied, and divided with fractions, and now you should be ready to practice on your own. Good luck!